Hello guys, how are you? As I mentioned last week, we will be working today, starting today with some video lessons. That means that I'll making a few explanations through this document. You can see here, today we'll be working on ratios. The idea is that you guys follow the discussion through my presentation and that you take notes on your notebooks. Remember that you need to show evidence that you've watched the video, so please be sure to write down each and every exercise that I'll show you here. And also, if you want, you can pause the video, try the exercise by yourself, and then continue the video so you can see the answer. The whole idea is that you follow the explanation throughout this 1 hour lesson. The video is not 1 hour long, but given that you have to pause, write down information, and continue, it should take you the complete lesson. Now, information regarding this video, please be sure to watch the complete video. Of course, throughout the process, if you need to pause or go back on the video to rewatch an exercise, is perfectly fine. Now, as I mentioned, there are exercises on the video, so you can solve them before I show the answer. Or you can wait until I finish the exercise for you guys to try it by yourselves. Now, remember that other classmates will be watching the video too. It will take them maybe more time or less time than the rest of you to finish. So please be mindful of the time and space needed by others to finish the task. And of course, please be active in terms of asking questions to others. Maybe something that you don't understand is perfectly fine for other person. So you can find a solution to the problem, or maybe other classmates might have the same question that you have. So please be sure to talk around with people around you. And finally, remember, you have to show evidence of your work on Google Classroom, so please be sure to complete the assignment by uploading a picture of your notebook where you show that you were working on this video. So let's begin. Let's start. Okay, so this video has to do everything regarding ratios. And ratios are very useful in mathematics, especially when you're trying to compare two amounts. So you can see here that the definition of a ratio is one in which you have two amounts, and the idea is that you want to know how many times one amount is contained on the other. Sometimes we call that A is to B. Normally what we do when we talk about ratios is that we use two dots, a semicolon, to point out the relationship between them. So normally we say, for every single amount of A that we have a certain amount of B. So the basic relationship between them is a relationship of showing how many times one is introduced in the other. I'll talk about a few examples in a few seconds, so this will be clear for all of you, but normally please be sure to point out this relationship. It has to be with a semicolon. That's normally what the symbol that we use to relate to a ratio. So let me show you guys an example of how this works. Now, before I continue with the example, take a look that this is a relationship that is quantitative, right? So that means that there are numbers involved. So it's a quantitative relationship, and the amounts must be written down by using the same units. I'll discuss about that in just a second. So let's talk about the first example. So take a look at the following example. In this example, we're talking about Eva. So Eva takes 30 minutes to do her work. In this case, we're talking about homework. And then Teddy instead needs 1 full hour to finish the homework. So there's a comparison in this case regarding time. So that is the amount we're going to compare. So Eva takes 30 minutes, Teddy takes 1 hour. And now Eva decided that she would like to write down this relationship on time by using the following ratio. The ratio is 30 to 1. So now we would like to explain why this is incorrect. Okay, so she is trying to make a comparison, and that's perfectly fine. They can compare each other because the relationship between the amount is time. That is fine. They are related regarding time. You can compare how much she takes compared to Teddy, but the problem is how she's writing the ratio. And the biggest issue here is that her time is being defined by minutes and his time is being defined by hours. So you cannot make a comparison by using different units. That's why this proposal for her is completely wrong. It is impossible that she's using a comparison where technically she's saying that she's taking 30 times more than what he's taking, when we really know that that's not true. So what we need to do is to change the units. So if Eva would like to compare her time with Teddy, there's only one way we can do that. We either change both and we use minutes, or we change both and we use hours. So if we would like to solve this issue in which the ratio proposed by Eva is wrong, let's make a comparison. So for example, if the whole idea is to move on minutes, we can say that she's taking 30 minutes and that Teddy is taking 60 minutes. So this is the correct composition between them. For example, 30 to 60. There we can see that she takes half the time Teddy needs. Or if we would like to focus on hours, then we can say that in her case, she needs half an hour, so 0.5 hours, compared to Teddy, that in this case, he needs 1 hour. So take a look how now those two ratios are perfectly fine on their comparison because we're using the same unit, either minutes or hours. Now, when we do this, we need to be sure that the units are not only in the same for both, but also that the expression makes sense for the exercise. What we know from the exercise is that Eva is taking half the amount of time than Teddy. So this is a way in which you can do the exercise. Now, important in terms of ratios, there are equivalencies that are associated. So for example, let me explain. If I want, I can rewrite this ratio by multiplying by 2 each expression. So if I multiply 0.5 by 2, that will be 1. And if I multiply 1 by 2 is 2. So what we can say is that those two ratios mean the same. Saying that she takes 0.5 hours to the hour that Teddy needs is the same as saying that her time is half the time of Teddy, so 1 to 2. What I'm saying with this is that you can simplify ratios or you can even expand ratios, but the condition is that you have to multiply by the same amount both. For example, in this case that we have 30 minutes against 60, I can make a small change to this one. What we can do is we can divide by 10 each. So we can have a new ratio that is 3 out of 6. Once again, the ratio is kept. What we're saying here is that she takes half the amount of Teddy. So if you apply the same operation on both ratios, the new ratio is equivalent. Or in this case, I was talking about division by 10. On the right side, I was multiplying by 2. So the important thing here is, number one, you're using the same unit, and number two is that you can multiply or divide by the same amount, and the ratio is kept. Going back to the definition, let me repeat, very important, we are comparing two amounts. Those two amounts should have the same unit. And remember, we're talking about how one is contained on the other one. In this case, that Eva takes half the amount of time compared to Teddy. Okay, so this is just a simple introduction to ratios. The idea is for you guys to feel comfortable by using this symbol. Let's continue with a few exercises. So, take a look at this example. Let's see if we can find the solution to it. So we have a group of children. They're choosing their favorite color. So we have people choosing red, people choosing blue, people choosing green, and the rest are choosing yellow. So the idea will be to write down the ratio according to their choices. And take a look that the exercise is quite clear, stating that you have to simplify the most you can. So let's write down those ratios. So let's begin. people are choosing 30% first. That will be for red. Let's continue with the second group. The second group are choosing blue, so that means 35. The second group, green, is choosing 25. And then finally we have a mystery amount that is the rest of the people, yellow. Now in this case we know that we can compare all of those quantities because they have the same, we're using the same unit. In this case we're using percentages. So those numbers over there are all at the same unit, and this should add up to 100%. Remember that this is a group of children, so we cannot leave anyone behind. So we have 30, 35, and 25. Now if you add 30, 35, and 25, what you'll see is that that's 90%. So we're missing a tiny little amount here, and the amount missing is 10. So now what we can say is that 30% red, 35 blue, 25 green, and then yellow 10%. What we can say from this is then that the distribution tells us that the most amount of children choose blue as their color of reference. Now, this is the choice. So what we can say is that, for example, yellow, the amount of people choosing yellow is 1/3 of the amount of people choosing red, for example. Okay, so this is one way of reading the ratios. Remember that we're comparing amounts, so we can talk about how many times one is contained on the other. And for example, if you would like to simplify this a little bit more, remember you can apply the same operation to all. For example, let's divide by 5. If you want to write down the simplest form, remember that if you apply one operation, it has to be the same operation to all. So if I apply that operation to this, the new ratio will be 30 divided by 5, 6. 35 divided by 5 is 7. 25 divided by 5 is 5. And then 10 divided by 5 is 2. So this is the same ratio. The only thing is that I'm simplifying the expression. So what we can say here is, now that I've divided, is that for every 2 that we have choosing yellow, there are 6 choosing red, for example. Or that for every 5 who are choosing, in this case green, there are 7 choosing blue. So it doesn't matter that you're simplifying. We're no longer talking about percentages, of course, because it doesn't add to 100, but the relationship between the amount remains. Take a look that even though I've simplified the expression, we still have that blue is the highest of them all, and of course yellow is the lowest one. So take a look that again, you can make comparisons between them, and the notation allows us to say how many times one is inside the other. That's why ratios are so useful in terms of notation. Okay, I hope this introduction to ratios is helping you guys understand the comparison between those amounts. Let's continue with the next exercise. Take a look at the next one. We have a group of books, and we can divide those books in pile A, B, and C. Now take a look at the comparison between the piles. We know that there is a certain amount of books in A, and that amount is twice as the amount we have in pile B. And then finally we have pile C, and pile C is half as many books as we have in pile B. So the idea will be to rewrite this as a ratio. Now for this particular case, take a look that pile B is the one that connects them all. So A is double B and C is half of B. Now, we don't know how many books we have on every pile, but we know the ratio between them. So let's fix an amount on pile B. Take a look that B is the one in the middle. And by doing that, then we can start simplifying or finding the simplest ratio form. Remember, we don't know how many books we have on pile B, but we can make, given that we're making a ratio and we can simplify, it doesn't matter which is the original amount. So let's imagine pile B has, for example, 50 50 books. Right now, we don't know how many books we have on pile B, but let's imagine pile B has 50. So if that's the case with B, then A has double the amount. So then A should have 100. And what we know about pile C is that pile C should have half as many books as pile B, so that means 25. So this is one way in which we can write down the relationship. Of course, this is not completely simplified. I will be able to simplify a little bit more, but take a look that this is a ratio that represents perfectly fine what's happening. The one that we're using as a reference is pile B. What we know is that A has double the size and C has half of its size. This is one option, but of course you can simplify this a little bit more. For example, what happens if we divide the whole ratio, and remember that we have to use the same operation. Let's divide the whole thing by 5. So if we make that division by 5, for example, we have, in this case, 100 divided by 5, that will be 20. 50 divided by 5, that is 10. And then 25 divided by 5, and that is 5. So take a look that if we simplify the expression a little bit more, this new ratio is also something that works because we have pile B in the middle, pile A has double the amount, and pile C has half of it. And even we can continue one more division. We can find an extra one and we can divide by 5 one more time. So we can find the simplest expression in this case, and we can say 4, 2, and 1. So this is the simplest expression we can find for this case. What we're saying here is that for every 2 books from pile B, we have 4 books on pile A, and for every 2 books that we have in pile B, we have only 1 pile in pile C. So take a look that even though I'm writing 3 different ratios, they all represent the same comparison. And the comparison is that we're using pile B as a reference. So whichever is the amount we have in pile B, we know that A is going to be double and C is going to be half. This type of relationship is important because the comparison will always be made. Let me go back to the definition that I talked at the beginning over here. Remember, we can make a comparison between amounts. In the last example, we were not talking about 2 amounts, we were talking about 3. But the relationship is still there. We are comparing them by the same unit, and we can say, and this is very important, how many times one is contained on the other. And that's important for you guys to take note of the definition because it helps us a lot to understand what's happening with ratios. Let's continue with a few more examples. So take a look at the following 5. The idea is to write the ratios in their simplest form, so we're going to simplify this the best we can. There are 5 exercises here. I'm going to solve the first 3, and I will allow you guys to solve the other 2 by yourselves. Let me explain what we're going to do. Be careful because some of them involve different units. So the first thing we're going to do is to change those into the same unit, and then we're going to simplify. Okay? And remember, in order for you guys to be able to represent this as a ratio, they must have the same unit. Let's begin with the first one. Okay, so in this case, we're comparing kilograms with grams. You have one option. You can work with kilograms if you prefer working with kilograms, or you can work with grams. In my case, what I'm going to do is that I'm going to work with grams. So instead of using 4 kilograms, I'm going to go for 4,000 grams against 500 grams. And this will allow me then to make the comparison. Take a look that now both use the same unit. And now that I have that, I can divide by the same amount. I'm going to choose divide by 100. So I'm going to both should be divided by the same amount. And by doing so, 4,000 divided by 100 is 40, and 500 divided by 100 is 5. Okay, so what we can say here now that I've simplified the ratio is that for every 5 that we have on the right side, we're going to have 40 on the right side. And then to finish, take a look that I can simplify this a little bit more. I can divide this by 5. So the final ratio is going to be 40 divided by 5, that's an 8. And then 5 divided by 5, that's 1. Now this is what we call the simplified version of the ratio. So what we're saying here is that for every 1 unit that we have on the right side, there's going to be 8 more on the left side. Or the other way to say this is that there's 8 times more on the left side than on the right side. And remember, you can simplify, but you have to divide by the same number on both sides, and they must have the same unit. Let's continue with the next one. Okay, exercise 2. We're comparing milliliters with liters. Once again, we have to choose the unit. In this case, I'm going to move towards milliliters. So we have 25 milliliters against 2 liters. And remember that 2 liters is the same as 2,000 milliliters. And now you have to choose. We can divide by 5, for example, if you would like to begin like that. Or if you want also, you can divide by 25. So it's up to you how fast you would like to make the simplification. In this case, I'm gonna use this immediately and divide by 25. And by doing this, take a look that the first one will be 1 against 80. 2,000 divided by 25 is 80. So in this case, I'm gonna leave the answer as it is. What I'm saying is then that for every 1 we have on the left side, there's 80 more on the right side. Don't forget, you can compare them, but the condition of the comparison is that they must have the same unit. So you cannot compare milliliters with liters. You have to change both to liters or both to milliliters. That will be exercise number 2. And then finally, wait, let me erase this. Finally, let's move to the third one. Remember, I'm going to solve 3, and then you guys will be the ones solving the other 2. For this case, we have pennies against pounds. You have to choose one unit. You cannot compare them if the unit is not the same. So let's make that comparison. Remember that having pennies is the same as writing it as 0.35 pennies. I'm sorry, yeah, we're no longer using pennies. We're now using pounds. And comparing 0.35 pounds with 4.20 pounds. Okay, and now what we can do is they're both the same unit. We're using pounds in both cases. So I can use an operation to simplify this. For example, I can multiply by 100 on both sides. So if I do that, I multiply 0.35 times 100, that's 35. And 4.20 by 100, that's 420. So as you can see here now, we're no longer working with decimals. They're gone. And now I can leave it like this. So what we can say is that for every 35 we have on the left side, we have 420 on the right side. Or if you want, you can simplify this a little bit. For example, I could divide by 5. That's an example of something I can do to change this a little bit. So 35 divided by 5 is 7. And then 420, that can be divided by 5, both of them, and that is 84. So that's the simplest of them all. So what I'm doing here is just referring to a new ratio. Now the ratio states that for every 7 we have on the left side, we should have 84 on the right side. That's the relationship between them. And very important, don't forget, they must be written down in the same unit. Okay, so exercise for you guys, so you can try and simplify this by your own way. You have 5 different ratios. The idea is to write this down in the simplest form. I've already showed you guys how to work with the first 3. It's up to you guys to find the answer for the last 2. And when I go back to you guys and check the answer that will be for the video number 2. So I'm gonna start the next video with those 2 exercises. So please try them by yourselves, compare the answers with the rest of the class, and we'll be back with the answer for the next lesson. See you guys with the next video lesson. That will be tomorrow. Thank you. Bye-bye. Don't forget to submit your evidences. Remember that you have to submit a picture of your work. That can be the summary of this